Okay, so I'll cover briefly what it's like, so you can kind of get a sense of how data is stored. I'm not going to go into the details of it, but at least you can see that how the way the structure is quite different. So let's look at the notes from here, and I'll try to explain. This is probably one of the more difficult lectures because it's really hard to illustrate. Okay, because indexes is just basically it's like a column or a pointer somewhere in your database table that points to data in the database itself. So I mean, it's really hard to illustrate that. So I mean, to create an index is very easy to do. Just write a single statement, you're done. But how the data actually gets stored and processed and queued into the server, it's quite complex to describe. This is not what I want. This is just the overview of that. I want to show you a different one. It's not here. Just give me a second. So let's see. Okay, let's show that one. Let's try this one. Run it again. Okay, let's see. Okay, so this is the one. It's not the best title yet, but for now it's good. Okay, so this is from the book I mentioned because it has a really good coverage on these data stuff. Okay, the book that we have does not cover this, so I just want to throw this out so you have an understanding of how data is stored, and then we'll go into the index, and hopefully you get an understanding why indexes work the way they are. Okay, so in databases we have these different terminologies. So we know that database is the highest level of storage, is the highest object in the database server, and then there's something called the extent. Okay, this is the basic unit, just like how we have the bit and the binary as the basic unit for binary numbers, right? And then we have 8 bits make a byte, and then 2 bytes and so on, right? So here we have the extent. This is the basic unit of storage used in the tables in indexes, and one extent is made up of about 8 contiguous 64K pages. Okay, we call those pages or data pages. So 8 times 1 data page of 64 is you get 64K. So a page is extent is made up of 8 pages, and each page has 8 kilobytes. Okay, and then your records are stored inside the page. Okay, so one row of data is stored inside that page, and then it'll keep storing until that page is maxed out of the 8K, and then it moves to the next page. Okay, page 2, page 3, all the way to 8 pages. If all those 8 pages are filled up, then it will create the next extent. It's the next row of data. So if you want to put that into a little diagram, you see something like this. Okay, so here is a data page. This is 8 kilobytes, and you have 8 of them. Okay, so one row here makes one extent. Okay, as data builds, as you add data to that table, then these starts to grow. Okay, so by default, one extent will have 64K allocated in there. And let's just say the first page here is filled up with some data, it maxes out the 8K, and then it goes to the next page. And then you keep going until you max out the 64K, and then once you have, if you have more data, then the database will allocate the next extent of another 8 pages. And it keeps doing that until you stop or whenever. Okay. The thing is that if you have like a record here, let's just say you're at the very last page here, and you almost maxed out the 8K, and your record has, let's just say, 10 columns, and the last column of data is gonna exceed that page. So what happened is that if that's the case, then it's gonna move the entire record to the next extent. So it has a new one below that, and then it will put the whole new record down here. So it's not gonna split your data, so half here, half over there. Okay, everything goes together in as one record. So in other words, it's not going to break your record into several pages. Either it's all in or not. Okay, so that's really happens, but it does happen that sometimes. So indexes. If you look at in the dictionary, it just means a way to arrange data in a certain order, so you can easily look at and find and that list of data, right? Even a textbook, if you look at the index of the page, it tells you exactly where it is. Imagine if there's no index on that book, how would you find chapter 8, right? Or how would you find chapter 12? I mean, to do it, you have to pretty much flip through the entire book until you find that chapter 8 or 12, right? Or you can maybe just guess in the middle, and then from there on you can go flip back and forth until you find that page number. But with the index, it tells you exactly where it is. If you look at the back of the book, it index everything in order. So if you just look at the name for chapter 8, it tells you to go to page 45. So that's what index is used for. Okay, it increases performance because it tells you exactly where things are located, and is usually sorted in, say, a database. So either from ascending or descending order, right? And you use that all the time up to this point when you create a primary key. The primary key is the index. Okay, that's why we say you have to have a primary key to sort your data. Okay, if it's not sorted in a certain way, then it takes much more effort for the server to locate a particular data. Because if it's not sorted, I mean, how do you know that Tom's ID of 25 is in the 25th position if it's not sorted, right? It could be the first, it could be the middle, it could be the last one. So if you don't know it, so what happened is, in that case, the database have to scan every row, right, until it finds it. Or maybe it could have multiple records of that ID, so it will find everything from that table from row 1 all the way to row N. And 100,000 records, not that big deal. But you're talking about 100 million records, yeah, that takes a lot of effort. Okay, so that's what the index is used for. There are two common options to sort data, and these are, you may or may not have heard of them before, but the binary sort and the dictionary order or sort. Okay, the binary sort, it just means you cut in half and then you check, right? So if you if you want to look for somebody in a telephone book, because the telephone book is sorted A to Z, so if you want to look for Tom, you would just cut in the middle, flip anywhere in the middle, and you check the page number or the letter in there. If it's K, then you know that Tom is on the right side of that, so you would just toss the left side and you cut the other half, and then you look in there, maybe it's under the S, so it's still going to be on the right side, so you keep dividing it by 2, right, until you find it. So that's binary search. Also binary sorting. It's basically you sort it in the middle, usually somewhere in the middle, and then you will go left or right depending on what the order is, right? So that's really important. Another is the dictionary order. Okay, this is like a dictionary would be like you have a key value pair kind of index, right? A key value pair. But sometimes it's kind of difficult because you have these accent symbols. Some data are stored using these accent symbols, those little strange characters because some foreign language use them, right? So if you have a database that stores those, then you have to search for those, and it takes a lot of effort. But let's look at this binary tree, this B tree here. Actually, in this case, the B is not binary; it stands for a balanced tree. It's commonly called the B tree. The B tree is usually it's a self-balancing tree. So if you look at this tree, I don't have the data here, but let's go into the book here. It shows a really good picture of what that looks like, maybe. Oh, what I meant by the accent was these characters here. So these are called the accent characters because they have a little character above it. Okay, so when you sort that in the dictionary, they come in certain order. So for sorting purposes, you kind of have to know how they are sorted. So it takes certain precedence. But let's see if there's a tree here. Okay. So if you look at this, this is like what's called a balanced tree or B tree, because if you look at this, it's nicely balanced between the tree. Okay, this is the root tree or the trunk of that tree, and then these are other branches, and they're evenly spaced out so that you have almost like, I mean, not perfectly in this case, but from the big picture you can see that it's really well balanced. Okay, so we add more data to this tree or this diagram here, then it's going to self-balance it so that you have evenly distributed. If you add like numbers more than 18, let's say 20 through 30, then you will see that it's going to add maybe another column over here. If you have a third column here, now the data are no longer balanced, so the system will automatically redo itself and will regenerate itself, so have a really balanced tree. Okay, you have an equal distribution between the left and the right side, so it's always balanced. Okay, so that's what's called the B tree. It's good because also when you search for it, then you know exactly which way to go. Because I can go on the left or the right, and usually have equal distance, so it saves you a lot of time. Whereas if it's not balanced, imagine you look for a number that would take a lot of effort to do that. So it's always balanced, and you don't have to manage that. The system does automatically. Okay. Let's see. I want to say something about how data is stored. Called the root, the leaf, and the non-leaf level. Actually, let's see. I think before I go there, let's go to the data first. Okay. Data are stored. So when you enter data into the database, even though we see that the data is actually inside that table, okay, it's not really there. When you do a retrieve, a query, it shows you the table of data. Because we see it that way, it doesn't mean that's how they're stored. How they're stored is based on the tree I just showed you here. Okay, so when you index it, so you have a primary key of ID, and what it does is that ID will be sorted in something like this tree here. Okay, I mean, we don't see it because you don't get to see it, but in the engine itself, it was sorted this way, so that if you search for a certain number, let's say I'll look for ID number 13, right? So as you can see, it will compare these numbers here because it's sorted here. We know that 13 is between 11 and 16, so it's in here somewhere. So it will look into this branch and here, and it's less than 16, and it's greater than 11, so therefore it must be in here. So it will go into this branch, and it branch down here, and will check these records. And then it knows that it's between 11 and 16, so it must be in here, and it will just search this part. Okay, so it's much faster than searching the entire tree from 1 all the way down to 13. Okay, so it breaks it this way. It's much quicker and much faster. So you have a root. You always have a root here, followed by the actual data. So it breaks it down this way, and this is more of what's called a clustered index. We'll talk about that, what that means later. So we have a cluster index will be like the root, and then you might have the actual data here, or you might have a non-leaf node, like this one here. You might have a second layer, okay, that will also point to another layer, And what we said, the leaf here is the actual data. So your information will be stored at the leaf level. If you think about a tree, the trunk of the tree is the trunk, the branch, and then the leaf contains the actual data. And it's stored this way, it's sorted this way, so when you look for ID of 90, and it will just go down this way because it's sorting. Okay, it's, instead of searching the entire tree, you know exactly where to go, and that improves performance. Okay, this is only for if you have a clustered index with a table that has a primary key, right? If you have an index, then it doesn't have this format. It's going to search everything in the tree, and so it's not efficient. Okay, so this is for a clustered index. The non-cluster index, which is something else, we'll talk about that later. It looks similar, but it has another layer below this. So we'll see the next picture down here. Hopefully, I think I saw it has one. So the cluster index, okay, cluster index, again, looks something like I just showed you here, right? So we have the root. So it breaks it down into the root level, the non-leaf level, it's like the branches, and then the actual leaf level. So it has 3 levels here. So your actual data are stored at the leaf level. Okay, so you can see that if you trace it, it takes much less effort to look for data. And then the non-clustered, we call something called the non-clustered index, okay, are similar except it has another layer down here. So your data will actually stored on the 4th layer we call the data pages itself. So the leaf level does not contain your actual data, but contains what's called another pointer to the actual data. Okay, so that's the difference between a clustered and non-clustered index. Just keep that in mind. You have the cluster index, the data are stored at the leaf level. The non-clustered data is stored at the data pages level. So you have another layer. Okay, so your leaf level contains a pointer to the other page. Okay, and so let's talk about the cluster and non-cluster, what they are. Okay, so the cluster index, this was incident data, how data are split. Okay, so we'll talk about table scan in a bit. I'll talk about cluster index right here. So you have 2 types, clustered and non-clustered indexes. So a cluster index is like a primary key. Okay, it's a unique key that is given to any table that has that makes a table unique. Every record, every row should be unique based on that index. And we use that primary key all this time so far. So that is a cluster index. And we know that each table has only one primary key, right? You cannot have more than one. There's only one per table. So the same rule applies that a cluster index, there's only one type. Either it's the primary key. If it's not the primary key, then you can create a different index and you make that a cluster index, and that will be treated like a primary key. Okay, some tables do not have primary keys. I'm not sure what kind, but usually you have it. If you don't have it, then you will create an index for that, and that will be a cluster index. So the cluster index, or the primary key, is what's called, well, you need that to actually physically sort the data. Okay, so a cluster, that's why there's only one clustered type. It's the physical structure, the physical way of how data is stored in that table. So if you have it so that you are sorting that table by ID, then that is the physical structure of that table. You cannot change the order, right? Everything is retained in that order. So again, the data are stored at the leaf level. Again, the data is stored based on the tree, the B tree, okay, the root, and then it will break that into the non-leaf, and then the leaf level you have the data. Okay, so just note that cluster index are store the physical structure of of your table. Okay. The non-clustered is also unique. You can make it unique or not unique, it doesn't matter. The non-clustered are You can apply that to multiple columns in your table, because maybe you also want to sort, you want to also index, let's just say, by the first names, right? For whatever reason. Maybe you also want to sort the table by maybe their ages or the salaries, right? And salaries can have duplicates, so they don't have to be unique, but they can be sorted in a list. So when they're sorted, it's much easier to locate. Okay, so a non-clustered is you can apply this to any column. You can have as many as you want. Okay, but there's only one clustered. You can have many non-clustered index. Okay, and you use, again, the purpose of index is just to sort a column so that you can retrieve, you can look for data much more efficiently. Okay. The only caveat is that every time you create an index, it doesn't matter if it's a clustered or non-clustered, you can actually, you have a duplicate column or columns in there. Okay, so the downside is actually it takes a lot of memory, because let's just say you have a table of 10 columns. Okay, you have a primary key in there for the first column of ID. Okay, that's a physical, the physical order of your table. So that primary key has the entire column as a separate data field, data in the database. You don't see it, but it's in there. If you have another, let's just say you create another index for, let's just say the salaries column, right? So what happens is that it doesn't just take that salary and resort it inside the table. You actually get a copy of the entire column, and then in itself take it out and then store that into a separate index. We call it the, let's just say, cluster index salaries. Okay, and it would sort that table or that column based on either ascending or descending order. So you get the actual data from that table. So the more indexes you create, the more memory it's going to use up, because it makes a copy out of it. Okay, so that's the downside of it. The good side is you can sort so much faster. If you use a lot of sorting, let's just say on the salaries, then you want to create an index for that salary column, because you can search much faster. If you don't use that all the time, you don't create it, because you're going to use a lot of memories on your systems. That's the downside. Okay, so it's not good to create indexes for every column. It's not good for not creating any indexes at all either. So you kind of have to pick and choose which one is the best one to use. Okay, just remember the indexes. It's like creating another table itself, but instead of having all the columns, you can pick and choose how many columns you want. Okay, so keep that in mind. Okay, so you create indexes. Just like you create tables. Well, not that difficult. Not more like a table, but much simpler. So the syntax is basically you create. These are all optional. Okay, when I put the square brackets, that is now required optional. So basically, create index. You give it an index name, and then we're on the table or a view. We'll talk about view later. Okay, a view is like a table. A view is a virtual table, really. Okay, so you can create index on both either a table or view. And then you put a paren here, and then in here you assign the column names. Okay, and then you set the column names to be either ascending or descending. If you don't put either one, I think it's defaulted to ascending order.
So if you don't put either non-clustered or clustered, what's the default on that?
The default will be okay. If you don't have a clustered already, because there can only be one. Okay, so if you have a primary key, I think the default will also be non-clustered. Okay, because you can't have clustered in two clusters, it'll fail. Yeah, so it'll be the non-clustered. It'll be non-clustered and also not unique, the default. So if you want to be unique, you have to force it to say create unique index, and then it'll be a non-clustered index. Okay. Yeah, these are optional. We're not gonna go to this much here. All we'll be doing is just basically just these lines here. Okay, you can apply multiple columns, not just one. Just like your primary key can have multiple columns, you can also do here as well. You can index 2 or 3 columns, and each column can be sorted in differently also. Okay, so that's also possible. Just remember that if you increase the column size, you're also increasing the data size because you're actually getting a copy of that. The other downside is because you have an index of the same data, if you add data to your table, or if you delete data from your table, what happens is the index also gets to rebuild every time. So when you delete data from your table and you click enter, okay, then the index also gets rebuilt and it takes time as well. So imagine if you have 1,000,000 records and you delete one row, right, one record. So when you do that, all the indexes you create, how many of there are, all of those have to recreate itself as well. 1,000,000 of those records have to be deleted from each of those, and so it has to have a live copy of your table. So it takes a lot of effort as well. That's why you don't want to build a lot of indexes for that reason, unless you really have to. But the idea of having indexes is just to improve performance when you query data. Okay, like when you search for a name and you use the where clause, where salary is greater than 35 and salary is less than maybe, I don't know, 55K or something, right? So that is where you actually comparing the values in the salary. If your salary is not sorted, I mean, how does it know where to start? Okay, so you have to sort the salaries column, and then from there on, you can find that data much quicker. So in that case, if you use it a lot, you will build an index on the salaries column so that the system will use it. Okay. The thing is also you can't force the system to use your index either. It's decided by the system. Okay, it's kind of interesting, but yeah, the system will calculate it. It will know which is the best way to do it, and it will use its own method. If you have the index available, and then if it finds that is the fastest way to do it, it will use that. Otherwise, it may not even use the index either. So that's another thing too.
So then how do you know if you created a useless index?
Yeah, that's a great question. Yeah. Well, I'll show you. You can actually see it too when you do a run, and you see that it may or may not use it at all. Okay. Usually, a small table. I mean, that maybe it's not going to ever use it because it doesn't increase the performance. Okay. If you run on a really large table, like I don't know, 1,000,000 records or something, then that becomes important. Okay. So in that case, I think you might see your index being used. Not only that, also depends on what are you looking for, right? If you're searching for a certain thing and that thing that you're looking for, it doesn't apply to the index that you create, it may not use that either. So it depends also what you're looking at. Okay. So let's see. All this stuff here, I'm not gonna do that. We're gonna talk about XML. We can skip the whole thing there. Okay, I think that's all I want to say here. So I think I'm going to go into the SSMS server and we're going to create some indexes.